All right, welcome back. This is Module 7, Chapter 14, Highway Construction Surveys. This is something you may run across. Eventually, you might be involved in some sort of highway where you're having to be the construction manager and you want to know what the plans look like and what they mean. But before you ever get there, you're going to be taught this information over again. And so we're going to go through it. I'm not going to ask a lot about this on any quizzes or well, not quizzes, but any homework assignments, weekly assignments, or on the final. Again, it's going to be theory you're looking for and understand the theory behind everything. So I'm going to go ahead and share my screen, and hopefully this will not be a long chapter because again, it's a lot of stuff that you are not necessarily needing to have for construction purposes. So highway construction surveys, there's a variety of different types of roads, local roads, collector roads, and then you'll see here arterial roads and a freeway. Each one of these is a level of service. A local road is going to be through your neighborhood, maybe getting to and from your neighborhood. So something like if you're going to the La Plata campus, um, shoot, I forgot the name of the road it was on now, but man, I can't think of Mitchell Road. The school is on Mitchell Road, and the Plata's campus is on Mitchell Road. Mitchell Road is a local road. A collector road would be as if you were coming in off of Route 6, or not Route 6, but like say Route 225. Uh, that that road there, Hawthorne Drive, that is a collector road, and that it collects people. It collects from one, and I'll get to it next, arterial road to another arterial road. So 225 or Hawthorne Road connects from 301 in La Plata, and it takes you out toward 210 in Bryan's Road. Both 301 and 210 are arterial roads. They very high capacity of traffic. They connect towns just like it says. And they also take you to the freeway, or in our case here in Maryland and Virginia, the Beltway. So these are the types of classifications for roads. And it's good to know them. It's good to understand them. This is a very bad slide, actually. Try to get in here a little bit more, see what's going on. So this is a base map that shows proposed street network. I can't even tell you what everything is because it is in such bad shape as far as how old this is. But one of the things you'll see here is these contours. I'm pretty sure we've looked at some of this before, but here's your typical contour mapping. Lets you know the elevations of the ground that you're proposing to put a road over. And lo and behold, you start designing with the horizontal curves, the vertical curves, the super elevated curves. You start doing all these things for design purposes to get your roads to fit and transition from one spot to another. So your book shows something on page 412, figure 14.1. You see a pile of photos, and the woman is looking at two photos at the same time. This is a stereoscope. It would allow you to see the elevations pop out of the picture because you were looking at the same thing in two different photos from a different angle and two different eyes on them, and you could see things pop up in 3D. Uh, Much like the glasses that you might have at the movie theater, those glasses that she has, she's looking through, were able her to see in 3D, and then she could map it. That's gone now. Now the 3D technology is on your computer screen. You will wear 3D glasses, better quality than the ones they give you at the movie theater, but nonetheless, you wear 3D glasses, and you will have filters over your computer screens, and you'll look at the same picture instead of, in this case, stereoscope overlapping, you'll be overlapped on the computer screen, and you'll be able to do the same thing. And the software nowadays is very helpful to allow you to draw the contours and draw topographic maps from photos. So we will keep moving here. You don't need to worry about this. All of this stuff here is on page 414 in your book. This is just ways to tie a point down. Surveyors tend to want to know, check themselves often, and you would get to this point and you'd set this 20 plus 0, 0, and you would turn angles to a couple different things, and you'd set points for offsets so that if you ever had to come back through here, you could check yourself to make sure you're in the right spot. It's a good idea. It's a great practice. It's not used as much anymore as it once was. And the biggest reason is because of the advent of GPS. What this is trying to show you is it's better for you to have 3 offsets, 3 tie-ins compared to 2. And yeah, it's something that you're not going to have to worry much about. Let's see, keep on going. All right. I'm going to try to zoom in on some of this. It's a little bit clearer in your book, but these are typical road cross sections. If you're going to lay out a road and survey a road, you're going to see this in a set of plans. And you might recognize the fact that you got some level ground, you get a ditch, and we come back up to the road. The road has a slight slope to it. It climbs up here and it goes back down there. You would stake this out, and one of the things that is showing you here is the different layers. So we're looking at gravel here, and we're looking at pavement right there on top of it. I don't know how much, no, I can't get any tighter than that. So these are pretty important, various different ways of looking at cross sections. This is your base course, and then this is your top course. So pavement is always done in 2 sections, sometimes 3 for thicker roads. You'll have gravel, and then you put a base course of pavement down, then you come back and you put a top course of pavement down, a top surface. Again, here is just a different variation of these are fill slopes. A lot of times you would have fill slopes and you'd have cut slopes, and you would have different, on a set of state highway plans, you'd have a different profile, a different cross section that is for each one, whether it's a fill, whether we're going to raise the road up over the existing surface, or we're going to cut the surface down, cut the existing ground down. So that's kind of important, but it's only going to be there for you if you're going to be building something. A lot of times, construction site, if you're doing a shopping center or apartment building, even with the parking lot in it, is not going to have anything like you're seeing here. This is only for highways. And you can see, if you were to stake out something like this is your typical interchange, right? I mean, if you were on the Beltway, this is typically what you have. Maryland, a lot of times we called them clover leaves. This is more indicative of something you find on, like on 95 even. Think about this. You have a curve coming through like this, and it transitions to a reverse curve going back out. You have traffic coming both ways. We have an overpass here. That also has a little curve in it. When you get off on these ramps have curves in them to bring you to a stopping point. As you excel back onto the road, that has a different curve to it. You see you had a curve this way, we reverse back into a smoother curve, and then we hit a straight section as we taper into this curve. All of this too could be super elevated, especially especially any of these off ramps, where you're literally making a really big hard loop here and coming back underneath. Maryland has a lot of them where you loop around and you'll end up coming back underneath here. You go under and you come over this way. So when you do that, these curves and off ramps and XL ramps are super elevated often. So you can see there's a lot of stuff happening uh, when you build an interchange like this. And I know some people that have done it, and it's a lot of work to make sure that everything is straight, but it puts everything we've talked about as far as horizontal curves, whether those are regular curves, whether they're reverse, compound, uh, or it takes into account vertical curves. Everything goes into play, as well as super elevation when you do an intersection like that. So you can see the importance behind it all. These are just a variety of cross sections to help you build something. You'll see it's a cut section, it's a fill section. Um, there's pavement for it. So it's just another way of showing you how something's done. These are called half sections. You would use this half section if you were in a cut situation where you're making a ditch, and you would use this half section in a fill situation where you're not making a ditch. You're just filling the ground up, and as you hit the existing ground, it sort of flattens out. So just different cross sections, different things you would use to stake something out in a set of plans. Um, Here is a typical plan and profile. Again, it's a very bad slide that we were provided. Down here, you have all your elevation data that corresponds to the horizontal data that's up here. So this is called a plan and profile sheet. It is a must. It's exactly what you have to have in order to stake out and build. I said stake out and build a highway. You must have both of them. Back to this again. There's just all sorts of things that go on when you're dealing with the intersection like that, and pretty much covered it. Now, here's something that you got to think about. This is the process involved, and now the book's beginning to talk about now construction of the highway. We have the design, and we just went over some of the layout for it, but here's where you actually have to build it. So a surveyor will come in and set the center line of the road. And from that center line of the road, the construction people would typically set a ditch line. They'll know where the ditch is going to be, and they'll set this stake here, this slope stake, this tie-out stake. And this is the point where you remove all of this ground and you stop right here. And at that point, you're going to be matching one of those cross sections we saw on how to build a cut section. And so that's what makes this important, is that in reality, your ground's all up here, but if you want a smooth section of pavement, you have to follow those cross sections, and that's how you have to grade everything and cut the dirt out, or fill it in some situations. See, here's a fill situation. You'd have the same thing. You'd have a center line of the road staked right here. It would be down here, and it would tell you how much dirt to add at that one spot. And then the construction people would pull all this information and get their slope stake where they tie in at. So that's, again, and this is for a fill situation, but that's how you build roads. You put everything we're talking about together, and you can even set your machine control to fill and cut and be able to build this road according to the cross sections. Grade transfer. There's a lot of different ways to transfer a grade. The one I don't know much about would be a batter board. This is when you're building a curb. It's a way to transfer the grade around. Or if you're building a house, you can do it that way too, by keeping your boards level. A lot of times with a curb, you'll see a carpenter's level is used to transfer the grade. The surveyors will stake the curb at a 5-foot offset, so 5 feet from the back of the curb, or the face of the curb, I mean, and then the guys that are putting in the forms for the curbing would use a 6-foot carpenter's level from the mark the surveyor gave them and set the forms to match that height. String levels would be similar. Most people for staking curb out, though, use a 6-foot carpenter's level. The laser is the way to go on parking lots and buildings and basements and any other sort of construction site. Not so much for curbing, but for anything else you're doing, these rotating lasers are great. They spin around in the middle of a construction site, and you set your pole to have a reflector on it that will respond when you're at the right elevation. It's an awesome thing. You know, I would say that if you're going to transfer grades, there's a lot of ways to do it, including the carpenter's level. If you're going construction management, you're going to want to use a surveyor's level. The level rods that we talked about earlier in the semester are total stations. You're not going to want to rely upon an old school method to be precise and as well as prove where you are and what you've done, because these have field notes involved to tell somebody exactly what you've done. Machine guidance, machine control can handle transferring elevations because it's got all the GPS on it and it knows what it's doing going up and down and checking everything. And again, the GPS is what is used for machine control, not so much the laser or sonic stuff. And this is just a general picture of how something might be staked and where you're checking things with a level rod. But let's just move along here. And this is for the batter boards. Again, it's these boards are set up so it'd be a certain height. And then you can use that to transfer your elevations from one side to another. But I don't see people doing that very often. So this was chapter 14. And basically we're looking at, let me stop my sharing. There we go. So chapter 14 was highway construction. And you see that everything we've built up to is sort of, or talked about, is built up to this point of actually being able to construct a road. And that's what the goal is, of being able to put down a bulldozer, have it move the dirt, have it fill dirt in, cut dirt out, make everything perfect so that when you put the pavement down and the cars drive over it, it's a nice smooth transition from tangents to curves, into reverse curves and back. Everything we've done gets you to a point where you can build. And so I'm going to go ahead and stop here, and we will come back in a few moments, and I'll be looking at chapter 15. And that also will go very quickly.